the first stream of making a game with Corona SDK. I'm just getting set up right now, making sure everything's working. Updating the Twitch stream. I want to make sure that everything's working. I'm not entirely sure I'm getting audio. Let's find out. There we go. All right, I'm going to turn off audio so that I don't hear myself echoing. But if audio goes out, hopefully somebody will tell me. Okay, here we go. This is the first installment in my series on creating a game with Corona SDK. I am doing this to, grow my experience with Twitch streaming, and I thought it would be fun to do something that might be educational and helpful to people. I also plan on making some tutorials about kind of key features, things like making sprite sheets and uploading them, things like that, file in-out stuff. Those I'll split off eventually, but this series is just going to be me making a game, so you can see what the entire process is like from start to finish, and follow along. And hopefully, as people find out about this, we'll get people in the Twitch chat who will then ask questions, and I can help people out. Otherwise, I think I'll back these up to YouTube, and people can watch them at their leisure. Alright, so for starters, we're just going to start a base project, and I like to start with the game project, because presumably we're making a game. And I name all my projects after Pokemon, because one thing that I've learned in game development is that, the game name that you thought you wanted, you're probably not going to get, because, rights, trademarks, etc. So when you're in development, it's good to use a name that you absolutely will not be allowed to use, because that way you're not heartbroken when the one that you've been using under development is taken. So I'm going to set it to tablet preset, because this game is that I'm making, which I'll talk about it as I go along, but I'm going to leave some of it as a surprise, and it might be a surprise to me. Anyway, I'm going to do tablet preset because this ideally will be played on a tablet, but feel free to set it to whatever you want. So the basis for this game is going to be a I'm going to make a folder here for it. My editor is already set up as Sublime Text. I highly recommend it. I love Sublime. It's got a lot of neat features. I feel like this simplicity of it beats out a lot of the complexity of a lot of other IDEs. Anyway, so the basis of this game, the start of it is going to be somewhat Farmville-esque. That's just to give you an idea. It's going to have a grid system. It's going to have elements on the grid that change, that kind of stuff. And I'll go into why I've made those choices as I go. But let's start off with just looking at the file structure and just taking a look at what Corona creates for you. Fascinating. I'm not seeing my folder. Okay. I'm going to close this for a second. It did not put it in the proper location. My fault. things I love about Sublime is being able to open a folder. That was not the folder I wanted to open. There we go. Alright. So, anyway, let's take a look at some of the files they have here. And actually, let's start by running it. So here's the game. It's got a little play now button. Ooh. Oh, yep. I just moved the structure, so let's go actually open the game. Here we go. Bulbasaur. Here's a game. It's got a little play now button. Kicks it off, and it's just this block that bounces and falls off the scene. That's their basis. Apple R will refresh it, so you'll see me do that regularly. So if it just starts over again, that's Apple R. Anyway, so here we go. Alright, so there's the background, which you saw at the beginning here. Build settings is some basic build settings. A lot of this has to do with iOS versus Android, and kind of like the setup. You'll see whether it's landscape, portrait. This is uploading the different icons you need for the store. We'll get to that eventually, I hope. I would like to show the process for getting things ready for the store. One of the most painful parts is getting all these images together, but I've got some shortcuts for that. And then there's other things like Android permissions and Facebook Connect stuff. We might get into this later, but just so you know, that's what that file is for. They've got an overstate and a regular state for this button, which is right here around this play now, but I'm not seeing it now, so my guess is that something about their default sample project is not up to date. We'll find out. Not going to worry about that right now. The config is another thing where you configure things like push notifications. This has to do with image loading, this at 2 times, etc. Has to do with if you're on different screens of different sizes, you can create different image assets. And the reason for that is that if you create an image that looked great at like 50 by 50, and then you're on this massive iPad or something, and it's blown up to 200 by 200, it's super pixelated. At the same time, if you're like on an iPhone, you don't want to load a 200 by 200, picture and then scale it down, because then that'll just kind of have a bunch of artifacting and make it look like garbage. So this allows you to take care of that, which we'll eventually get to. FPS, I believe this allows you to limit the frames per second so that they don't go over this. So the ideal being that whatever you have the limit is not something that you ever you like set it so that generally this is what it's going to run at, because you don't want to drop your frame rate a lot, but you also don't want it to speed up and go faster than you expect. So this is a good base frame rate. Letterbox has to do with their scaling. They have automatic scaling tools, which are really good. When we get into talking about different size platforms, which the simulator can show you some of these, these are all different kinds of things that Corona will run on. Here's their example of a Kindle versus, an iPhone 4. All these different sizes. You can see this letterboxed, so it maintains the ratio of the base game and then just puts in these letterbox bars. They have other versions, scaling, stretching, and stuff. We'll investigate that later. But my goal here is to get into making a game as soon as possible, something interesting, because all the parts about like actually releasing a game are tedious, and if you don't even have a game, it's hard to spend the time doing all that to release something that you haven't even made. what I was on. Oh, the mini. Okay, I like the mini. It's the right size on the screen. Alright, and then there's a bunch of images for their little thing. You saw the crate that fell. This is, oh, when it loads up, you may be able to see it. It's there super quick. But like when you open on an iOS or Android device, it has a default screen that opens up. I also believe that Corona uses certain images at certain size, these defaults, to basically infer what devices it's usable on. So if it has like one of these opening images of a given size, it'll know like, okay, that's for the iOS iPhone or something, and then you have a different one that lets it know like, oh, that's for the tablet, so this is a tablet and iOS device. These are all icons, which are, interestingly, they used to be a little Corona icon. They might still, so one thing to know is that when you actually build this, you go to File, Build for iOS, that took a lot longer than I would have expected. We're not going to put a distribution out. Anyway, if you're going to build for iOS, what this does when you build it is it calls out to their server and it builds all your code and then sends you back the finished product. You know, that's how they were able to sell this as a service, is that, you know, you don't have the tools to actually take your code and turn it into something that can run on a device. So they may actually replace these images when they do that, so who knows. Got a logo, yeah, it's just the game title. And then you've got these basic elements. So all of that stuff, all these images, you're eventually going to replace with your application's icon. And actually, let me open up one of my previous projects and I'll show you what this might look like. Give me 1 second. It would have been helpful if I had organized everything ahead of time. But, you know, you got to jump in and just start making stuff. You don't want to waste your time not making stuff. It's very easy to make excuses not to make stuff. So, yeah, one of the problems is that sometimes I forget what Pokemon name I used for a given product. Once it's like out there, this is Star Panda, which you can go check out in the iOS or Android App Store. But anyway, here's the icons. So you can see these are all different resolutions, and there's a whole thing where I can't remember which. I think iOS automatically crops the corners, so you get the nice like rounded iOS app look versus these squares, but the Android doesn't. So like I have cropped versions, and these are like super pixelated, right? Because they're gonna appear very tiny on a screen. They're gonna appear like, oh no, they're gonna appear like this, super small, where they're nice and clean. But this is the reason why you have to worry about images at different sizes, is that depending on the machine, you know, it may or may not look any good. So anyway, we're going to get to all of this stuff as we go. So the first couple things are, I'm going to add a folder for assets. So unlike their, lost my folder menu. Oh, duh, I forgot. It's Sublime, their little folder things down here. Anyway, we're gonna add an assets folder. Unlike this sample project, like they have a very flat structure for two purposes. One, I'm sure it just makes it easier, simpler, everything's in the same place, you don't have to like look for anything. But also, because of the way iOS works and their build tool works, these things have to be at like the top level so that they get picked up automatically. However, things like this crate, which are just part of the game, like I would normally put in an assets folder so that, you know, there's some kind of organization. as you can see from my previous project, Star Panda, which maybe I'll just keep open over here on the side. Sorry, I got distracted looking at the Twitch chat. I keep a very flat structure. I mean, this is a very simple game, so I didn't spend too much time organizing this, but you know, the bigger the project, the more you want to organize your code so that it is actually usable. So we may do some of that later on, but let's go look at some of the basics of this. Oh yeah, their sample moved over to using Composer. Now they have their own thing called Storyboard, and I have no idea why this uses Composer directly instead of their storyboard version. I want to eventually figure out if they have decided that you should just use the default Composer version, or if you should use their storyboard version. I don't know, but I know that I believe the storyboard one still works, so we're going to use that. I'm going to grab a project that I had been working on just as a test that will speed up some of this development so I don't have to look up things. Okay. Let's open the folder here. Okay, it's helpful to keep this guy open. Oh, I got a cat. Say hello to the stream, cat. This is Maybe. She's gonna help us code. Okay. So the first thing I'm gonna do is I got from the internet, like if you just search for class code, you can find it pretty easily. There's this sample code for writing a class. Why won't it let me just paste it? Some things I find slightly annoying about a Mac. One of them is copy paste. Anyway, this class code is just basic implementation. Here you go. Actually, here's the URL, which I'm going to share this code. Like all this code, I'm going to eventually load to GitHub and share. Like I'll share the links and everything so that everybody can get all of the code. But yeah, you can see this link. This Lua users wiki, simple Lua classes. This is like an implementation of a class. And we'll get into that later, but I find it super, super useful. So I wanted to get that, and then I just realized the real thing I wanted to move over was the storyboard implementation. So we're going to go grab that. As you can see, I name everything after Pokemon, so this one was Pikachu. Yeah, here we go. See, so this was the other implementation. It used to just be storyboard, and you'll see that the implementation is pretty much identical. I'm just a little more familiar, and if I use any of my libraries of code that I've written, it's nice that they all use storyboard instead of Composer as the name. But it effectively serves the same purpose. So we're going to get that. And then let's take a look at the opening menu. Actually, I think what we're going to do is skip the menu. Yeah, like I did here. So what storyboard does is it allows you to change scenes. So if you look at this, we're on this default scene, and then you play now and it fades over to this other scene. It's a really helpful tool for navigating scenes in your product. It depends on what your game is. Like for instance, Star Panda doesn't go through many scenes. Like it's actually like you open it and you're in the game and you start it and it just goes straight into the game. Whereas I have another game called Last Thumb Fighter, where it has a single player, multiplayer, and then cooperative version, and those are all different scenes, and so they have nice transitions and everything, and storyboard allows you to do that fairly easily. So we're gonna go to this. We're gonna make our base scene, which is gonna be Bulbasaur. All right, I'm gonna put the cat down so I can type easier. Okay, so one of the things is a lot of people will go back and forth on whether they feel that you should preface names of things with like the name of the product, like Bulbasaur in this case. I believe in doing this because when it inevitably happens is you want to use something from one place in another app and you don't want to have to go rename everything. It's something that I've done before. I've taken an entire game and put it in a different game. And so, you know, in order to do that, you need things to be named differently. Otherwise, you'll be screwed. Oh, 1 second. So that's what we're gonna do for most of this. We might change that eventually later. So yes, as you can see, this goes to the first scene, which is Bulbasaur game scene, which doesn't currently exist. So we're gonna get one of these. So if you look at their level 1, they have this base scene, and this is what I was saying. Like they're using Composer. It's 90% the same, but then you have things like, oh, it's called Create Scene over here in the storyboard version, which actually, yeah, I mean, so like it could have been named anything. Like these are the event listeners, so when a scene changes in the storyboard or Composer, you get an event, and you get an event for Create, Show, Hide, and Destroy, which this sample project, I believe, tells you what they are. Yeah, so Create is called when the view never doesn't exist at all, where you have your initialization code. Show is when you're showing it again, where you've moved away from it and you've come back. And some of this stuff, it's very interesting. You get into it and like when these events are fired on iOS or Android based on, you know, if I'm in the app and then I moved away from the app, and then I've come back to the app, something like that, you know. Sometimes those trigger these different scene changes. So it's helpful to know that. Looks like this Twitch stream may have had issues. I want to make sure that that is still running. We will find out. Of course, there's advertisement. Anyway, sorry. So the scenes, as they change, you know, based on whether or not you've like moved from one scene to another, and then also like if you leave the application or come back, or if there are memory issues, like scenes will get like destroyed or dropped or hidden. So it's, you know, this is something that we may eventually get into to make the app more performant. One of the things I've done before is like destroy a scene when you leave it, so you don't have to worry about that kind of stuff. So yeah, that's what it is. Sorry, just turn on the sound to make sure that a Twitch stream is good. Okay, so anyway, we have these different listener events. The way this works is when this event gets fired, Create here, it triggers it on scene, and it has, so there's a connection of this object in this Composer and storyboard are a perfect example like why I do object-oriented programming in here. It's because, I mean, these are similarly like a product, or I mean like an object, where here's a scene and it has a function create, and so when this event listener fires, its name, this is the name of the event, and under the hood it's saying that like, hey, when you get a create event, call scene create, which is this function here. So storyboard's version, instead of just create, show, hide, destroy is create scene, enter scene, exit scene, destroy scene. As far as I know, they're identical. It's just like these are maybe better names. And then these functions match up, where this is going to call create scene on the scene object, or the object that you pass in here. And so that's why, of course, I like to use storyboard for everything, because then it's compatible with all of my old code. Let's take a quick look at what's going on this composer side before we go and gut it and make it something else. So when you open this screen, you actually went to the main menu. I'm not going to refresh it now because it's going to be overridden. But that first screen that said, like, you know, game title and then had a play button, that's this. So on create, you have a group. Now, groups are going to be how you arrange the different elements and keep them together in groups, so that you can refer to them, move them, hide them, delete them, etc. Here's the background that we add. It's just a simple display of an image, and then setting its location, etc. Title, same thing. And then you have one of their widgets, a play button. Now, I have my own version of a play button, but I may go back to using their widget. I'll have to see if their widget works at all. I ran into an issue in a very old version of Corona where the widget button wasn't working, so I wrote my own button to work the way I wanted. And that's what I've been using. I may still use it, we'll see, but as I've mentioned, you know, I'll make all my code available, so whether you want to use theirs or you want to use mine, it's up to you. And here's where things get inserted into groups. They don't really have anything going on in the show. This is good to know. They have two types of events, like will show, which means like, hey, it's not on the screen yet, as you can see, like they say here, called when the screen is still off the screen and it's about to move on. So the idea is that you have this window that you're watching. Oh, let's make sure I'm on screen. You have this window that you're watching, and then when you're going to transition to another one, they create this one, and then you get the will event on this one, as in like, hey, this one is about to be shown, so do anything you need to do to set it up. And then as it moves over, this replaces this one, you know, whatever the transition is. It might be like a fade or whatever, and now this one's here. And then when it is on the screen, you get the did option, so that you can you know, as it says here, make it come alive and start timers and begin animations and everything. Same thing with hiding. You know that, like, hey, here's your two scenes. This one is about to go away, and we've created this other one, so do whatever you need to do here to stop everything. And then when it actually does hide, you get the did event. I don't think the same goes for destroy, which is why I don't have an example here, because this could be dropped at any moment for a variety of reasons. Like it might, you know, you might be running out of memory, so they just have to drop it, so you don't get a chance to do anything with it. And you know, create is sort of similar. You can't do anything with it before it actually exists. Oh yeah, of course, like, yeah, why would you have a will and did on destroy either? Because, like, if you did destroy it, it doesn't even exist. You can't interact with it. So anyway, that's the gist of what happens. As you can see, like, all that happens here is they have the background, the title, and they add the play button. And the play button has a function on release, is this function. So here we go. And all this does is go to a scene, and look, it has a fade, and this is how long it takes to fade. This is in milliseconds, and there are 1,000 milliseconds in a second, so this is half a second to fade. And then this return true, you'll see this for different touches, and it has to do with, I believe this controls whether or not pass-throughs happen, which is to say, if you have 3 things on top of each other and you touch, if you don't return true, I believe it'll continue activating on subsequent elements in the thing. But if you return true, this thing will get touched, but the thing behind it won't get touched. I believe that's what that's for, but I will remember when we actually have to deal with that. So anyway, that's basically what happens here. That moves on to the level. And the level, you know, has a new scene that just sets up the basis of working with scenes. And then it starts physics, so you saw the block fall down, hit here, and bounce off. That's using their physics system. So they start it, like they create it, and they start it and pause it. I would imagine they start it here because there's a not insignificant amount of time it takes it to start. So like they want to start it before the scene is ready. And then when you actually show it, they'll start it like, so they start it to make sure it's like ready to start, it's been initialized, and then they pause it so that then you can later start it when they're ready, and then when they hide it, they stop it. And this is like, so imagine if this wasn't here, this stop function, I just got rid of that. That would mean that it would start, and then if you say you're on an iPhone, you navigate it away, you come back, and like that block is gone. Like you started it, it was here, and you moved away, and you came back, and then it's gone because it bounced and bounced off, and you weren't there to see it. Whereas if you pause it, when you're hiding the screen, it means that like, hey, you left, but when you come back, everything's where it should be. This is the destruction of the scene. This clears out everything. This stuff is very important. You want to unload your memory. I believe there's some elements of you know, memory management in this, but some of it you kind of want to do manually so that things are quicker, so you don't waste a bunch of memory when you don't need it. So, you know, that's the basis of what is here. And then they have a bunch of helper functions for the size. I do a similar thing, and we'll get into that. Oh, you know what? I need to remember that I have the pause button to cut out my audio. We're going to test it right now, and we'll see if it works. So, cool. It looks like it works. I need to get good at like pausing it if I am sneezing or something. Yeah, it'll come with time, of course. So, okay, here we go. So, so that's how things go. Let's go see what this looks like. So before this went to the menu scene, their menu here, this name, is a reference to the Lua file that has a scene in it that is your, you know, the scene that it's going to. And as you can see, when this goes to level 1, that's level 1.lua. So for starters on ours, we're going to change it over to here. We're going to go to our Bulbasaur game scene, which doesn't exist yet. Oh, and this hides the status bar. The status bar is at the top, and it's the like battery symbol. I'm just going to look at my Android here. It's like your wireless, your time, etc. My advice is, you know, don't get rid of that necessarily unless you have to, unless it, you know, kind of detracts from your game, because it is very annoying to play a game and not be able to tell what time it is, or if your battery is about to run out. I feel like some places do that because they want you to forget how long you're spending with their game. But I don't know. I don't know that that's really necessary or that it really detracts. I'm probably going to misspell Bulbasaur a bunch on accident. Oh well. These are not automatically going to save as a Lua file, so you need to make that a .lua. So we're going to save that bad boy. And then, of course, it breaks. So I have this set to automatically rerun every time code changes, which will be annoying because I have a habit of auto-saving, which you should do. You should save and save often. But you'll get things like this. Go to function scene main.lua11 which this is actually a perfect time to talk about debugging. So this is called a stack trace. When something happens and it breaks, you'll hopefully get a runtime error like this. There's also a panel. Let's see something. Oh no. Sometimes you can open the terminal with it, and you can actually just see it in the terminal. We'll do that later, but you'll normally get a nice runtime error like this, and it says, hey, the global scene name is a nil value, which means that it doesn't exist. And so that traceback is in main.lua 11 in the main chunk go to scene. So main.lua 11, oh, fancy that. Or go to scene. Oh, but Bulbasaur game scene exists. Why might that not work? Well, that's because there's nothing in this file. There's no scene. So we have to actually create that scene. So we're going to take from this code. I'm going to start with the basics here. So first off, you need a storyboard and a scene. You got to create the scene. And that's important. I like having these lines up here. As you can see, this was previously a level 1 file, but it is no longer. I think it's kind of silly to put like the file name because you know what the file is. But eventually, we'll put maybe important information in this. By the way, this is a comment if you're not used to it. Comments in Lua, they start, this would be interpreted as code unless you comment it out so that it is not interpreted as a comment. I just got a note that my voice audio is really low, so let's turn that up. Audio. Let me see something. Let me test my audio right now. Is it low? Is it too low? Yes, it might be low. Sorry. Would be good to have good quality audio. Let's turn up the input volume. See if this works out. Well, maybe it's a little better. Here. Testing 1, 2, 3. Okay. I think that is much better. I might have to adjust the gain in the initial stuff. We'll have to check that next time. Alright, sorry for that brief interlude. Okay, so this is a comment. Here you go, it's comments. These 2 hyphens commented out. In a lot of other languages, it's done like this. But in Lua, it is done like this. And what that does is it tells the code when it's running to just ignore this line, don't do anything with it. And that's how we can drop in messages to ourselves or future users or other programmers, etc. So we're going to then grab this. Again, I'm going to put all this stuff up on GitHub and make sure that you know how to get it down from GitHub, so that you don't have to go and copy this. But you can easily take like the base level one and edit it, and I wouldn't be surprised if one of the other samples actually has this code. So yeah, this has the same kind of comments. Called when the scene view doesn't exist, called immediately after a scene is moved on, called when it's about to move off screen, etc., etc. So this is also a helpful note down here that the destroy scene event is dispatched before the view is unloaded, which can be automatically unloaded in low memory situations or explicitly via call to purge scene or remove scene. So in my other games, I have had to use purge scene and remove scene to get rid of this as necessary. But yeah, in low memory situations is when this is most often going to happen, and your device needs to get rid of it so that it doesn't crash. So anyway, here you go. Here's the basis of it. We're going to comment this out. The Apple / is this, if I believe that's correct. Apple / on a Mac, probably, or command, I still call it Apple because it used to be the Apple key. Comments out things if you, in Sublime, if you're selecting a whole list. So this will make it so that what's happening here is we've got our scene, the create scene, enter scene, exit scene. All of this is pretty normal. And nothing actually is happening here. It's just got scenes. So hopefully when I save this, this reloads and voila, we have nothing. But that's exactly what we wanted. So now let's actually make something. So I was going to explain a bit about why I use the classes. Yeah, the reason I use a class is because it helps me a ton in organizing my code. We're going to be creating a lot of objects. For instance, the basis of this app is going to be tiles in a grid, and we're going to build all those different tiles, and we're going to manipulate them in different ways. So abstracting that as a class, an object that we can manipulate, is very helpful, and I hope that you will see that as we go along and build this. Now, I actually should just run this Pikachu game because then you can see what some of the early stuff is going to be. This is a different experiment I was making. Oh, but it can't run because it has a problem in its main Lua 13 Pikachu game story. Oh, you know what? I think that our game scene. I think that I was messing with stuff when last I left off, and therefore it doesn't actually run. So we'll ignore that for right now. We'll switch back. But anyway, I'll probably show that on a future stream. But we're gonna probably build it right now. So if we get far enough along, you'll get to see exactly what it's like. So anyway, my class structure, I always start with a base game, which envelops the entirety of the game. So we'll take a look at what one of those looks like. This is the base of it. Hopefully this is not too daunting. Actually, what I wanted to start with, before we get into how classes work and everything, I want to start with just drawing a rectangle. Which this is the reason why I am sharing the full screen, because I want to be able to show you how to look stuff up. So Corona SDK has this handy dandy API reference, which you should bookmark and use all the time for anything you need. So we're going to just draw a rectangle on the screen. Here's display new rect, and you can have an optional. What you'll see a lot is these. This is a method. I mean, they're essentially effectively doing the equivalent of object-oriented programming here. Like, you know, this is your display object with your new rect function, and it has this optional parameter. So that's what it's called when it's optional. So here you could just do the x, y, width, and height, but parent will tie it to a group, which is these display groups, which I referenced. For instance, you put it in this group, the view that is the scene, and that gives you control of it as this as a part of this self view. So the self view is a group that's already tied to this scene, and if you then later want to delete it and everything, you can get access to it. I'm probably not describing that well, but that's okay. We'll ignore that for right now, because you don't need it. Let's start with just drawing a rectangle. Here's a perfect example. Let's just take their example as is and drop it in. So there you go. It's off screen. So here's the thing to note. So you can see this is 150 by 50 stroke width 3. This is the stroke is a reference to lines. So like this is the line around the box, that red line. And its fill color is, I believe this fill color is, as with all of these, like same as the stroke color. This is RGB. Oh wait, this, okay. Yeah, it's a gray. So the stroke color is red because these three are RGB, or red, green, blue. And one of the most annoying things about Corona is that there's different ways of representing red, green, and blue. For instance, and I may go into this later, into the details of like why this is, but these are normally represented as a number, like 256. And so you'll often see things where they're a number 0 to 256, 256 being full red, 0 being no red. But they kept switching between that representation and a 0 to 1. So for something that's like kind of half red, you might have like 228 in this system, but in the system that Corona has now, you do 0.5. So we'll take a look at that in a second. And then this version, so this fill color, they could have given an R, G, and B, but they didn't. They just gave this one value, and this one value is applied to all of them. So it's just like a shorthand for doing this. So we're going to take a look at that. So full all colors is white, so we're going to do 1 there. And then we're going to leave the red. So we save that, it gets reloaded, and hey, there you go, now it's white. Did I change something else? Oh yeah, I changed it to like half red. This is 0.5, but that's okay. That doesn't really do anything. Okay, so what I want to point out is this is 150 by 50, and it's a square, so you're probably wondering why we're not seeing our square. And that's because the center of the square is right here. So the rest of it is over here outside of the screen. And the way that you determine that, where it is, so for instance, we can change its X and Y location. So let's make it 150, 150 so that it's on the screen. So there's a few things that you'll notice now. Now I just moved its position. So its position, give me 1 second. Try to find reference images to show you. Okay, here we go. So I promise there's not going to be a lot of math, but you should learn math. It's not really that hard, especially if you start to use it all the time. What you can in games, but there isn't a lot that you need to know, like multiplication, addition, subtraction. You need to know what there are and when they're used. You don't really even need to know how to use or like how to do them because, that's what a computer is for. It's in the name. It computes things like math. So anyway, this is a grid system. You might be familiar with math. So horizontal line is the X. As you can see, it's labeled X. Vertical line is Y. Now, what you'll be wondering is, okay, if this is 150, 150, where was it before? So you know what we're gonna do? We're gonna make a second grid. Apple D, or Apple Shift D is how you duplicate in Sublime. So just duplicate all this code. You'll see me do this often as well. If you hold down the command key, you can select multiple places and type in them all at once, so you can do cool things like changing the name of this. So if you are wondering what the heck's going on, you know, that's probably what I'm doing. So let's make one at half this, 75. 75. And let's make it black on the inside, and then we'll give it a green stroke. RGB. Okay, so there you go. So now you've got to be wondering, in our classic grid system, which you probably had in a math class at some point, if you start going higher on the X, you go to the right. If you start going higher on the Y, you start going up. Now, why is that not happening here? Good question. I can't tell you. I used to know because I looked it up once when I was a kid. You can Google it. It's not important. What you need to know is that in this grid system, and in most computer graphics grid systems, like you'll find this is very, very common. There is a reason that you start at the top left. So it starts here and it counts down is higher on the y-axis, and to the right is still higher on the x-axis. So there's a good reason for this. I don't remember what it is. Look it up if you're, you know, the kind of person that wants to know. If not, you don't really need to know anything other than it starts up here and that higher on the y goes downward. So anyway, yeah, as you can see, this is your whole box. Now here's the thing that I want to get back to. When we created it, its x and y is by default 0, which you'll learn. Now why is that here? Well, it's because there's a concept called an anchor. And an anchor is whenever you're manipulating an object, like this rectangle, you need to know where you're manipulating it from. So, for instance, I'm going to take this cool poster thing I have. If I had this up here and I want to rotate it, well, I can rotate it around its center like this, where the center here stays stable and I turn it, you know, or I could rotate it by the top right corner where my fingers are. So I could rotate it like this, where that point stays stable and everything turns. So that is called the anchor point in Corona. You'll see it in a lot of different things. If you're familiar with any graphics programs like Flash creates objects, and you can see the anchor and you can drag around the anchor and say like, I want it here. And then it'll rotate around that point and move based on that location. I will be showing graphics and stuff in Flash as we move on to making game graphics. But anyway, the default center point is for that anchor. So you have anchor X is the center. So now I have to remember, because this too is something that has changed before, how they determine the anchor point. They used to have something where you say like top left center point, or like bottom left or whatever, but now they do it with an anchor, and the anchor has 3 locations, and I think they're -1, 1, and 0. But anyway, I think 0, 0 is in the center. So we're going to move these. I'm going to move these down real quick. Okay, so 0, 0 is the center, I believe. So if we do this again, nope, 0, 0 is not the center. Let's see if it's, oh, you know what? Maybe it's 0 to 1. I have an idea. Let's do, so here's the thing, I could look it up, but I could also just play around with this and find out pretty quickly. So I'm going to do the latter, just because it's what I like to do sometimes in order to, you know how things work. You know, I am a game player and programmer at heart. I don't want to have to look it up. But, you know, regularly you should probably look it up. So what we're going to do is we're going to put these at the same location so that we can tell what's happening. Okay, so this is 150, 150. And this is 150, 150. So I think it's here because this is 0, 0 and that's 1, 1. And so yeah, let's make a third rectangle. And we're gonna do this fancy technique that I love to use. Oh yeah, you might want to give it different characteristics so we can actually see it. We'll go back to gray center for that. Save it, rerun it. Okay. So -1 doesn't do anything because it is overlapping our 0. Huh. All right, we're gonna, oh, would be helpful if I had anchor X and anchor Y. Okay, so that was part of our problem. Let's put our anchor X and anchor Y. Now things will be more interesting. Okay, so now the anchors are, so that makes more sense to me. Okay. So the default 0, or actually no, the default is probably not 0. The default is, so this is, I believe this is the 150, 150 point, but 0 is the left of the object. So in the case of the red, 0, 0 is at the top left. 1, 1 is the right. So then if you do 0.5, 0.5, you get halfway between the two, and that gets you this. So actually, that would mean that the starting position, starting position, the default is 0.5, 0.5, which we'll find out by getting rid of that. Where did our rectangle go? Oh, yeah. It's behind the other ones. I wanted to also get rid of the X and Y location. Okay, so that's at the start. Now if we change it to 0, 0, see now it's at the top left. And this is one of the things to know about strokes is oftentimes like strokes for a line, if you use them in any different system, oftentimes they are not a part of the actual element. So if you had this nice white square and then you have a stroke that is this line, it's outside of the element, which is why on the top here stroke gets cut off because it's technically not the 0, 0 is where the white starts and not where the red starts. Okay, so if we put it at 0.5, 0.5, we're going to get where it started. So there you go. It's good to know. So the default is 0.5, 0.5, which is the center of the object. But if we want to use the top left, which generally, like, this is one of those things that will mess up your head if you don't keep it straight. You want to keep all of your elements either defined by their center or defined by their top left, because it'll help your sanity a great deal. Okay, so that's how you draw a square. So we've already got something going, which is good. But sorry, I would like to. So an interesting thing about Twitch is that if you use OBS, which is what I'm using, I think it's called Open Broadcasting Software, is a really great, super simple streaming service. However, the way that it interacts with Twitch, it does not trigger a tweet, which I'm going to so I'm gonna tweet that out real quick. Take a little break. Everybody, get a sandwich, go to the bathroom. Twitter's word count. All right, first. All right. Anyway, we're going to continue on. All right, so we've got our square, rectangle. It's not a square because it's got a different size. So that's where I just wanted to start. I just wanted to make it so that, like, hey, look, you've got an item. It's on the screen. Something's happening. That's fun. It's exciting. Now let's move that thing. So there it is. It's on the screen. There are event listeners. So there's 2 major event listeners that you're going to use. You're going to use the touch, because presumably you're doing some kind of touch device thing. I know, well, unless you're doing a Windows or Mac OS app, which Corona is now going to have support for, which is pretty cool. But let's say that you're still doing a mobile. You want to get the enter frame, the touch event listener, which I'll show you how to add those later. We've got touch stuff in there. But the other one is enter frame. So enter frame is that one of the things to know about how computers and graphics work and everything is that every time your program runs through, it's got what it's supposed to display on the screen. And that goes in frames. And you're familiar with frames from like watching movies or animation or anything, where the individual stills that one after the other make the screen what it is. Now there's all different ways that this could be handled. You have this, and it depends on like how a screen is drawn. For instance, there are certain types of screens where the hardware requires that light be shot out to everything at once, and it all changes. And then there's the other kind where it's like, I believe this, I'm not entirely sure, but then there's like the most common is the kind that like shoots each pixel one at a time, changing all their colors, then goes out, starts it over again. And so there's all these different elements to that, like where you can make it more efficient by, like, if a color is not changing, you don't have to resend that value, etc. All of this to say that, like, the way that we're going to interact with it is in frames, and those frames update, one after the other, and it's the whole screen. So what we're doing is we're setting up a bunch of things like this rectangle, and every time that it draws, it knows, like, hey, this rectangle is here, its location is there, starts here, ends there, we need to draw it. But this is also, how you get updates. Like Corona system has updates, and they happen on these frames. So we have this frame, enter frame. We're gonna get rid of this extra stuff. So just like these event listeners down here, this one is runtime because that's the kind of the runtime system that's running everything. We're gonna add an event listener for enter frame, and we're gonna tie it to this on enter frame function here. And what this enter frame function is going to do is whatever we want. Now, there's a concept of scope, which I don't want to get into too much detail about right now. But the idea is that objects live in a particular place. And in order for them to be referenced in other places, they need access to them. So here we have this rectangle that we created. And this should not work. So what we want to do is take its X location, and then we want to move it 10 every time that the frame enters. I'm going to save that. I'm going to load. Oh, and what's wrong? Why can't we reference this myRectangle? Well, the problem is that this myRectangle, this is a reference to this object. And this reference lives only in this local place, which means basically between the start of this function and the end of this function is where this myRectangle lives. Now, we have, by doing this display new rect, we've created it, and it lives also somewhere else in the internals of the system that tell it to draw on the screen. However, it does not live for our purposes outside of this function, so we can't reference it. So how do we reference it? Well, we need to move that reference outside of both of these. So now the things at this level are at the start of their respective function and the end of their function. Now that is because this is a scene that is kind of like out of our hands, but for the purposes of this, imagine like these, well, and actually technically I think these are in the global space, but we're going to ignore that for now. We're going to just focus on the fact that, like, if you think about where a function starts and a function ends as being a little block of space, it's called a scope. This space here, things that are local are only known from here to the end there, and that's it. And if you're outside of this area, you cannot reference any of those. So when we move this rectangle, the reference of this rectangle to out here, it means that we have access to it. Now, we don't want to create a display until we have a screen, so we're going to move this in here. We're going to go myRectangle equals that. And here, we're just going to leave the rectangle reference. We can actually do like equals null, which just means it's not there. But what this does is it says, like, hey, this rectangle exists out here. And so when this says myRectangle, it's actually referring to the one that's out here, which then we can reference inside this function. So if we save that, hey, look, there it goes. It's running away. It's gone. So what happened? All right. Oh, actually, in Lua, they use nil, not null, to mean nothing. But I'm not going to go into that too much detail unless somebody asks about it. But nil, null, they're effectively just mean it's nothing. There's nothing there. But why are we doing this? So this is like essentially a label that references this object, and it needs to live in this world out here where everything has access to it, versus being just in here in this function, where only this function would have access to it. So now it's referenceable here and here. So there we go. We have a location, and hey, it moved off screen. And if we rerun it, there it is again, and it just moved off screen. So now let's go add touch. Normally, like I said, I work with objects and classes, but I realized as I was doing this that it's more interesting if I just get you to where you can have interesting interactions, and then we can build the niceties of like code constructs that allow you to manipulate this stuff in a more sensible fashion. But for now, like, let's make it cool and easy and simple, so that we have access to, or so that we can do something fun. Because hey, I don't know what you want to do. Maybe maybe you just really want to make a square that runs around the screen, and that's it. And that is totally cool. Okay, so we want to add an event listener for touch. Oh, good. So, I want to look up the reference for touch real quick. API. Somewhere on this page. There we go. Touch. Let's go see. We've got an example. Yeah, okay, here we go. That's what I thought. So here we go. We're going to add an event listener, and here's the function on object touch. So there's an object that this is the object, and we have an event listener for touch. So when this object gets touched, we're going to trigger this function. So in this case, we're going to take our group, which is the entirety of, well, so in this case, our group will actually just be composed of this rectangle. Actually, there's nothing in the group right now. So let's do that first. We're just going to insert our rectangle into the group. That will become clear momentarily. Oh, as a note, because you may wonder about this, semicolons come from other programming languages, and they mean the end of a line. Like, hey, stop here. This is a complete thought, essentially, and the thing after it is not. For instance, this is like, hey, my rectangle's anchor x is 0. That's it. In other languages, you have to have a semicolon, because otherwise it will interpret this as if it were like this, which makes no sense and it would break. However, in Lua, they just imagine that you've put exclamation or semicolons at the end of every line. Now we can get into why other languages don't do that. Eventually I could talk about that, but it's not really that important. So out of default, because I'm most often programming in other languages, I tend to put the semicolon, but you don't have to in Lua. So that's why so don't be confused when you see that I've used it some places, but I haven't used it others. It's implied. The other thing to note is that you can use it in Lua to do things like this. If I put that semicolon there, then I put this here, that means that when it runs this, it goes, okay, da 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 da, oh yeah, we're gonna stop here, and then this is a new thought. So you might see that in other people's code. I don't really use it that often, but yeah, you can still use the semicolon to great effect in Lua. Okay, so anyway, so when we add the event listener, we're going to touch and we're going to give this function. I'm not going to use self. I'll show you self later and what that means. But let's have it be, we'll say move block. Okay. I'm gonna add this function. Now, touch has an event. So self is the object that got touched, and event is the event. So there's different events, like it begins, it ends, and it moves. Those are, here you go. So there's, the touch can begin, it can end, or it can move, and it can end or be canceled. We will get into some of that stuff later. But for now, we're just gonna like lock it to the began, so that it makes it very simple. So we're just gonna copy some of this. Actually, I'll just write over here. So over here. So remember this. So self and event are the two parameters. So what happens is, like, somewhere in here, when an event touch happens, it says we're going to call move block. We're going to do this. This is called a function call. It's going to move block, group, and then the event. Like, well, event is actually an object. So anyway, we'll get into all that. I should probably explain function calls, etc. Eventually, but there's going to be a little bit, and this is very common in programming, is you have to you kind of have to just deal with the ambiguity and not knowing what things are. Eventually, as you get to the point where you understand how functions work, you understand how code is executed, and what methods are, and how data works, etc., you'll eventually get to the point where you can take a step back and say, okay, what is this? This is a function with a string of touch or whatever, and it's being passed another function, and it's got an object that it's being built off of, etc. And then you can kind of go through those pieces and look through code and understand how it works. For now, I'm just going to teach you like how to do things. For the most part, I'm going to try to keep this stream to just like, hey, this is me making a game, even though I'm going to try to explain everything I'm doing as I go. And then eventually, like, I want to make out breakout tutorials that actually like tell you what a thing is and show you examples and take you directly through, like, hey, this is how it works, this is, you know, etc., etc. For now, we're going to focus on just getting it done. The hope being that, like, you know, this is for people who, you know, have played around a lot, know something about languages, but don't really know how to make a full game, because they run into like the millions of issues you run into when making a game. Oh yeah, there's other things. So these brackets, which do not work in Lua, or I believe they don't work in Lua, are how other programming languages define. So that thing that I defined as scope, which is this chunk right here from start to finish of a function, this is how you do it in other languages. You'd have these brackets that indicate it. In Lua, it's just indicated by the start of the function and then the end. Now you might be wondering why this end does not conflict with this end, and that's because this if then starts a new chunk, and it ends right here. So this needs an ending first before that needs an ending. Anyway, so when this happens, we're going to take my rectangle and we are going to move it. So if we're doing that, we're going to comment out the one in the enter frame so it doesn't just immediately run off the screen. And we're just going to move this manually. And then, as I said, like, you do the return true to cut off that function. Okay, so we've got a block. If we touch it, something went wrong. Index event nil value. Ooh. Sorry. Yeah, so we want to hit continue so that it stops complaining. So there's different types of listeners. Oh, sorry. Yeah, I was looking at the wrong one. So you'll see there's different types. So this has self event on this object. That's because an object was passed in. In this case, it's a function. So there's just event. So I actually should have this event. We'll get into the this other version because that's what we'll actually be using. But for now, we just want event. I knew something was wrong with that. Okay, so I can click around, but if I click on this, hey look, it's moving when I click. And that's because, here we go. So, you move the block when there's a touch, and that is added on group. Now group, because of this my rectangle, consists of the rectangle. So I believe if we cut this out, save it, the group doesn't exist. The group is not on the screen because there's nothing in it. It has nothing. So when we add this event listener to the group, it's not connected to anything. So yeah, we actually need it to be there to be something that you're clicking so that it can actually work. So we're going to put the rectangle back in the group. Now the rectangle's there, and hey, when I click it, things happen. That's great. So our next step is to, for now, what we're going to do, so we always get touch events, is we're going to make this rectangle the entire screen. And to do that, you have this handy dandy content width and content height. And that is the entirety of the screen. So we're changing the size. Oh yeah, so a rectangle, if you go and look it up in our handy dandy API, X, Y with height. So this is the width and the height. So we're changing that to be the full displays width and height. So there you go. Takes up the whole screen. If we click it, we're adding to its X. So again, in case any of that wasn't clear, we have this rectangle and we have an event listener for when we touch, and it's on the group, which the rectangle is a part of. So that means that clicking the rectangle is clicking the group. When we click the group, we move the rectangle, which is why if you click over here in this black side here, it doesn't move it because this is the group. The group is the rectangle. That's all it is. Okay, so there you go. We've got something to start with. That's good. So let's not move the rectangle. Let's instead make a different rectangle. And we're going to make something a little more fancy with it. So first, what I'm going to do is I'm going to change this my rectangle to the background. And for now, we're going to change all the references to background. And this is just going to be a background rectangle that we're going to use for a touch. And like I said, we need something to touch. And so if I just want to touch the whole screen, like I need something that I'm actually touching. So we're going to use this rectangle in order to do that. And then we're going to make a new rectangle, which we're going to think of as our character. So let's change it to character. Based on the time, I think I'm just going to make this something that we can play around with. And I will start off next time by converting all this stuff into the way that I do code with classes, etc. But for now, we're just going to make something cool that is fun to play with. So let's make this 20 by 20. We're going to make it green because why not? Oh, that's a stroke color. I'm going to get rid of the stroke Don't want it. In fact, I'm gonna get rid of it off the other one too, because it's just clutter. You know, if you're doing anything more than a rectangle, like, why not do a graphic? So again, this is these 3 RGB. So we're gonna make it green. Get rid of my commenting code here, so that this becomes more clear. Cool. So we have this other character. We're gonna insert the character into the group and the background into the group. So the background is there, and our little character is there. And cool. Let's save it. See if that exists. All right, there you go. A little green character at the top left. That is a very bright green. So we're gonna make it less so. That did not have the desired effect. Okay, there we go. Nice little kind of forest green. Okay, so now what we're going to do is we are going to do the same thing that we did and move its x. Now in other languages you can do this. This plus equals, it says that we want to add 10. But that's not a thing that you can do on Lua, unfortunately. So you have to do this longer version. Oh, and this is something I should explain because I've heard of people having problems with this. The equal sign in math that you're familiar with, that you've used probably all your life, is different than this equal sign. With this equal sign, so in math, you're used to saying like, hey, x equals y. It's like, okay, well, if then x equals 4 or 5, because that's what I typed, then y must equal 5, right? Or let's say if x equals y plus 1, then you know that if y is 5, then x must be 6, right? Because you could rewrite this as 6 equals 5 plus 1. That's how math works. That is not how programming works. In programming, what you're actually saying when you say, let's say like x equals 6, is like, I want x to now be 6. And here, I want x to now be, or y to now be 5. Now this, like let's say it looked like this. You're saying I want x to now be y when you do this. And therefore now x is going to equal, like if we printed out x so that we could see what it is, which I'll talk about later. You have to have the terminal running for that. But if we printed that out, then x would be 5. Like at this point, x is 5. Because we want x to be what y was. So in this case, so this is one of those things where now if we say x equals x plus 1, or that's not possible in math, like unless x is, or yeah, sure, it's not possible, I think, unless I'm thinking of, there's some situation that I'm not thinking of. But anyway, the point is that like, yeah, this doesn't make any sense unless you can find a value that is that. In programming, it means that whatever x was, we want to add 1 to it, and then we want to make x that whatever that is now. So if x equals 5, then we say we want, so this is 5 plus 1, and now we want x to equal 5 plus 1, which is 6. So now at this point, x equals 6. So it's a quick little explanation of how the equal sign works. So when we're doing this, we're saying, hey, whatever it was, like its x location is 0. Actually, we're going to do this with the y location as well. It starts at the top left, 0, 0. And we want to add 10 to both of those whenever you click. So now I click and hey, look, it starts moving. Plus 10, plus 10. It's great stuff. So that's how that works. Now, let's say we want to do something a little more interesting. Like we want to take into account where I've clicked. So let's go take a look at our touch, find out how we figure that out. I already know. I'm doing this for your benefit. So you need the X and Y of the event. Now, there's all these other properties of the event. So here you go. If you look at this, we touch, we get this event. Event is an object with a bunch of properties, and those properties are these. So the X and Y are the mouse X and Y location. So we're going to do, whoops, I want to do this. So whatever the character's X was, we want it to be our event X, and whatever character's Y was, we want it to be the event Y. So there you go. So you can see the event X and Y are the location of the mouse when I click a touch. So it's going to jump to those different locations. So that's interesting. We got something more now that we can work with. But what if we want it to move around? Not just hop location to location. For that, let's say that we wanted it to slowly animate from there to here. What we're going to do is we're going to create a destination location. So I realize that this is a little bit back and forth between like a teaching session and showing you how I make a game. That's okay though. I want to make sure that if somebody comes across this, there's a video somewhere that teaches them the basics. We'll move a lot faster once I get into actually programming the game I want to make, but for now we're going to make this fairly easy. Okay, so we have a destination X and Y. And we're going to set those to wherever you click the mouse. Now, that's for starters. That means under the hood, when I click here, destination X and destination Y have changed, but the square is not going anywhere. So what we want to do is now update that. So let's get our little character. And there we go. So this is back on enter frame. So this is, again, remember, this, whoop. What did we miss? Character X. Oh, haha. So, a thing to note is this on enter frame. So what this is complaining about, let's get that complaint. We're trying to index up value character, which is a nil value. So character is nil. Of course, it's nil here. But we make it not nil here. However, what this means is that enter frame is getting called before character exists. So we're going to do this, and this allows us to check if it exists. So now character exists, and now, interesting. We have our enter frame. Sweet. Oh wait. Trying to remember how to do this in. Oh, that's not what I want. Oh, haha. Okay, so here's what the problem is. No, So yes, character doesn't exist. Now the question is, why does character not exist? Because hey, we've made character down here. Well, I'll tell you why. Because I put local here. And what that means is that we wanted this character to be the local character, which means it only exists between the start of this function and the end of this function. Of course, that is not what we want. We want that character to be the one up here. So in order to make that happen, you're going to get rid of local, save it, and there we go. And he's off, and he's just gone. Okay, so now every time we enter frame, that character's location gets updated. Now what we want is it to go to destination X, destination Y. So we're going to do this. So this is an if-then function, which pretty much works like it sounds, but you're going to have to know what some of these symbols mean. Okay, so this is an if-then statement. So it says, if this condition is true, then do this. Otherwise, don't do it. So what this symbol means, so here's the thing. I said that this, well, it's actually, there's a representation right here. This equal sign, just equal sign, says, hey, take this value on the right and assign it to this value, or this, reference on the left. Now, if we wanted to say if the character X is equal to the destination X, we cannot do this, because that, again, says destination X, we're going to put that value in character X. So how do we say if it's equal? Well, you do double equals. So this says if the character X equals the value of destination X, then do this. So that would mean that, like, if I clicked right where the character's X was, it would move 10. But if I clicked anywhere else, it wouldn't. So what we want is not that. What we want is if the, so this is less than. So here's less than, which you should be familiar with from math. This to the left is less than this to the right. People say there's a little alligator and it eats the bigger one, whatever. That's less than, this is greater than, X is greater than destination X. But we're going to do, so we're going to do less than. We want it to move to destination X. And if it's, but we also want, so if it's less than, we want to add 10. So if it's, here's here's the square, and here's the destination, or here's the destination. If this is less than it, then we want to add 10 until we get to it. If it's greater than, we want to subtract 10 until we get to it. So we're going to do that. It's greater than. There you go. So that's only on the X location. So we're going to click here, and hey, it's greater than, and it's going to keep going, and now it's stopped because that's where I click. So if I click here, so in that case it was greater than, and we're going to keep subtracting 10 until we hit it. And we can do the other way, right? So now it goes back and forth. Now you have like the basis of a game where this could drop stuff and your character could collect it. Who knows? Maybe I'll make that game real quick and then move on to another one. Who knows? So let's do the same for Y. I'm just changing all these values to Y so that the same works for Y. Alright, now we save it. And here, now I can click anywhere and it'll go. Now you can see it has that fun, like, it'll hit one location here. We'll go here. See, so it moves along, moving 10, 10, and then when it hits the place where it's in line, then it's only moving the Y, and then it changes how it goes. And that's the basis of moving something around. So that's the basis of touch, the basis of an enter frame event, the basis of drawing something on the screen. We've got covered a lot of bases here. I think I'm gonna go for another 20 minutes. So we're getting into what else I can add before we get into the whole class stuff. I don't want to jump into class stuff yet. So instead, I'll get into something a little more complicated. Yeah, so actually let me point this out. So it's moving by 10. So if I click here, it's not always exactly where I am going because let's say, I wonder if this is a good opportunity to look up kind of paint tool. Let's find out. See if we can find it. Nope, that's not what I want. Let's hope they have a demo app. Cool. Okay, this is all I wanted. So here it is, and then these are increments of, oh yeah, sorry. I'm going to say this. Here's increments of 10. Here's our square. Here's increments of 10. So this is 10. This is 20. This is 30, 40, 50. Now what if I put it at 52? Let's say that's where I clicked my mouse down right here. So what's going to happen with the square? It's going to move from here to here to here to here to here to here. Now, it's less than, the x is less than the destination x. So we're going to add 10. It's going to move over to here, which is 60. Then it's going to be greater, and let me think. So it's going to be greater, and then it's going to move back. So actually what we should see is shifting. Let me see if I can manufacture that. Let's make this like, or actually let's make this 50. To make it more pronounced. Interesting. All right, so we might attempt to break out the terminal for this because I want to see what's going on. Actually, so let's quit it. See, I think it pops the terminal anytime. Ah, there you go. Nice. Okay. Yeah, so normally when you start up, you get this terminal, and the reason for that is it's helpful to do this. Here we're going to print out to that terminal the characters X and the characters Y. I hope this works. I don't remember. Lua. Okay, cool. Oh yeah. We're not printing this out because it's just XY. Those don't exist. We want character X and character Y. I'm gonna save that. And okay, character X and character Y are 0. Interesting. Yes, they're 0, 0. Okay. Okay. So yeah, they're moving to 3,500, whatever. Now what I want to see though is what is the destination X and the destination Y. So there's no destination X or Y. Now there's destination X and Y. But now they're nil. Oh, I know why it is. No, I don't know why it is. Alright, so let's get rid of those. And then let's do this so we can see what destination Y and destination X are. You always want to trust in the auto complete of Sublime. It'll help you with the typos that I'm making. So here's X, here's Y, and it looks like the reason these were null is because I didn't spell destination correctly. In fact, I managed to do it wrong multiple different ways. Okay, there's destination X and destination. Okay, so there's 0. They were 428, 384. So that's fascinating. Because how interesting. Okay, so what we're gonna do to experiment with this is we're gonna slow it down. So what we want to do is every 10 frames. You'll see this, what I'm about to do, repeated often. So we're gonna say I is 10, and if I is less than or equal to 0, then we want to do all this stuff. Otherwise, don't do anything. Oh wait, that's not true. Otherwise, we're going to take I and we're going to take 1 away from it. So what this means is that when I is less than 0, we are going to, or I mean when I is greater than 0, we're going to take 1 away from it until it hits 0. Then we're going to do all this, and then we're going to set it back to 10, and then we're going to go back to taking 1 away from it until it hits less than 0, and then we're going to do all this set. So this means that this happens every 10 frames instead of every single frame. And actually that might be a lot. So let's up it to let's up it to 30 so we can see it every second. Okay, so I'm going to place a location. And it's moving. Now, this is curious. So every second, the character's location is 350 and 450. The destination is 480 and 362. So why is it not still moving? Well, this is perplexing. So normally, what you'd see is jitter. So what would happen is, it would say, hey, oh, you know what? We're going to do this for fun. We're going to make a little destination indicator. Hopefully all this stuff is going to be visible on the stream. I haven't really been looking at like making things highly visible. Let me make this green square bigger. And we're going to make a red square. And then what we're going to do is actually we can just get rid of destination X and destination Y and actually make them this object of destination X. And and destination.y. We're going to replace those. We're going to replace these. Oh, and we're going to have to replace these, and we're going to have to replace these. And then we get rid of this destination X and Y. There we go. Okay, so now I click, you see the little red dot, and it's going to move towards the little red dot. Fascinating. I don't think that little red dot is very visible on the screen, so I'm going to make it into a bigger red dot. We're gonna, so I keep changing these numbers, this like 50 say, we're gonna change this to 100, but we're gonna call it move speed and make this function so that we don't have to keep typing it. And this is why we have variables, because why would I want to have to keep changing every place that I use this instead of just one place? Okay, there's our little red dot. And it's going to it, it's going to it, and now a very curious thing has happened. It's not on the red dot, but it's no longer moving either. And I'm trying to figure out why this is. So let me actually change this, so this makes more sense. We're looking at it, and click here. So you can see, character is at 400. 400 is less than 480, correct? And in that case, we should be moving it. That is weird. Well, I may have to puzzle over this and come back next week. Unless they are doing something crazy, which I would not believe it if they were, that keeps this value from continually ping-ponging back and forth, which is what you'd normally see. You'd see it's less than the X, so we have to push it to the other side. Oh, no, that's working. Yeah, it doesn't, if I move it left or right, does move in every direction. So what you normally see is it's less, but so it adds the move speed, but now it's more, so then it has to subtract the move speed, and the object should ping pong back and forth between those two. Same with the Y direction, but it's not, which it doesn't make any sense. Anyway, I'm going to investigate that. There's no reason to keep the feed going. I think this is far enough for today. The future of this project is interesting. I'm going to try to continually put in a couple hours every week to build this game from the ground up. We're going to do graphics. We're going to do all kinds of fancy things, all in Corona SDK, with the idea that if you follow this along in a short order, you will have a game that you can make and play. Ideally, this will not take, years. It'll take, maybe a few months. But we'll see. We'll see how it goes. Hopefully, this was enjoyable. And if you have any questions, feel free to contact me. I'm going to move these windows out of the way. So you can see on the feed, right around here, TylerMakes.com, where all of this stuff is going to be posted, as well as their links to the Twitch stream, or add me at TylerMakes on Twitter, and you can follow along, subscribe, etc., and find out when these streams are happening. They should happen every Friday, so I'm going to try to keep on that schedule. And they should happen probably between 1 and 2 usually, or like starting at 1 or 2. This one started a little late, but we'll see. I'll fall into a schedule a little bit as I make more progress. But anyway.